Theories of time and space in the universe. The concept of time and space has always been of great interest to humans, especially when it comes to exploring the vast and complex universe we live in. Over the years, scientists have developed several theories to explain the nature of time and space, and their interactions with each other. In this article, we will discuss some of the most significant theories of time and space in the universe. Classical physics. In classical physics, time and space are considered separate entities, and they are independent of each other. Time is seen as a universal constant that flows at a constant rate, regardless of the observer's position or velocity. On the other hand, space is considered as a three-dimensional entity with fixed properties. Special Theory of Relativity. The special theory of relativity, proposed by Albert Einstein in 1905, revolutionized our understanding of time and space. According to this theory, time and space are not separate entities, but they are intimately connected to each other. This theory suggests that the speed of light is the same for all observers, regardless of their relative motion. This means that time and space are relative to the observer's velocity, and they are not absolute. General Theory of Relativity. The general theory of relativity, proposed by Einstein in 1915, built upon the special theory of relativity and proposed a new understanding of gravity. According to this theory, gravity is not a force but a curvature of spacetime caused by the presence of mass and energy. This means that the presence of mass and energy warps the fabric of spacetime, causing objects to move towards each other. Quantum mechanics. Quantum mechanics is a branch of physics that deals with the behavior of matter and energy at a subatomic level. According to this theory, time and space are not continuous, but they are made up of discrete units called quanta. This means that space and time are not smooth and continuous, but they have a grainy, pixelated nature at the subatomic level. Loop quantum gravity. Loop quantum gravity is a theoretical framework that attempts to combine the principles of general relativity and quantum mechanics. According to this theory, space and time are not continuous, but they are made up of tiny loops. These loops are the building blocks of space and time, and they give rise to the smooth and continuous spacetime we experience at a macroscopic level. M-theory. M-theory is a theoretical framework that attempts to unify all the known fundamental forces and particles in the universe. According to this theory, there are 11 dimensions in the universe, including the 3 dimensions of space and 1 dimension of time that we experience in our everyday lives. The extra dimensions are curled up in tiny, compact shapes that are too small to be observed directly. M-theory proposes that our universe is a 3-dimensional membrane or brane that floats in an 11-dimensional spacetime called the bulk. The interactions between the branes and the bulk give rise to the fundamental forces of nature, including gravity, electromagnetism, and the strong and weak nuclear forces. Time travel. The concept of time travel has been a staple of science fiction for many years, but is it possible in reality? According to the laws of physics, time travel is theoretically possible. Einstein's theory of relativity suggests that time and space are intimately connected, and the faster an object travels, the slower time passes for that object. This means that if you could travel close to the speed of light, time would appear to slow down, and you could effectively travel into the future. However, Time travel into the past is more complicated, and some scientists argue that it is impossible.